Okay, so this it is okay. So this book is moving like this, right? Okay. Okay, so where we are, this is the height and this is the time. Okay, and here the y component is missing. So what I can say, the y component it will be given by, you can say vy. It is always going to be, you can say initial component. It is going to be minus half gt square, right? Right. So there is a g which is going to act downward, right? We know that. So this is vy. Okay, so finally it is time t. So at time t, this is vy component. Okay. Okay, so then can we find the height? So how to find the height, and then what is going to be vx? Okay, so let's see vx. So vx is going to be, you can say that is v naught. Okay, so this is v naught, and this is into t. Okay, so this is only you can say it has been come like this. So it is, you can say v naught into t, that is vx. Okay, so my velocity vector will be given by, you can say it is v naught t I plus minus, sorry, this is minus half gt square. Okay, that is you can say okay, so you can say this velocity vector will be, it will have the two component, that is vy, which is like this, and this is vx, and the total velocity vector will be like this, and we can find the magnitude by you can take magnitude of v vector will be nothing but vx square plus vy square, because the two components are perpendicular to each other, right? We can apply this formula. Okay, now let's see. Okay, so this is the velocity. So can we have an idea about the height? Because the height okay, so what will happen if okay, so this time if v naught is, you can say it is okay, so you can say what is asking is that if the initial velocity of the book is doubled, what happens to the time the book is going to be in the air? Okay, since the height is same, and if you double this also, okay, so you see that the height, it is going to be determined by, you can say h, it is going to be initial velocity vector on the y direction, that is 0, it is minus half gt square, sorry, this is going to be, this will be minus gt, right? So that is what it is going to be, and the height, it will be given by minus half gt square, right? Because here y component is 0, right? So it is minus half gt square, right? So okay, so it depends upon the time, and time is, you can say here it is vy is minus g by t. Okay, and this time to reach the ground, and this time will be given by, you can say, now how to find this time, let me call this distance as so if this is height, so it depends upon this height, and it is asking about this. Okay, so the time, you see, it is 2h upon g, square root of this is the time, right? So this is the time to reach the ground. Yes or no?
Yes, sir.
Okay, so this is the time, so it is independent of the horizontal component of the velocity, right? So there is no v, you can say mu naught over here, so it is independent, of mu naught, right? So hence there is no there is you can say no change in time, it is dependent upon the height. Okay, the tabletop height is the same, so hence there is no change in the time, so that has to be the answer of the a part. Okay, so a part answer will be, there is no change in the time. Okay, the horizontal distance of the book travel while it is in the air. Okay, horizontal distance, now you can see that this is the range, right? So this horizontal distance, it is given by x is equal to v naught, you can say this is v naught into t, because there is no oscillation over here, so ax is equal to 0, so it is v naught into t. Now if you see that this distance, let me call this as x1, that will be v naught into t. Okay, and if you double this to v naught, then this horizontal distance will increase. Okay, so you can say this x2, Okay, so this is 2 v naught into t. Okay, so this will increase, horizontal distance will increase, okay, but time to come down, it is going to be the same. Yes, is that okay?
Yes, sir.
Okay, so that means the range is just going to change, but it is not going to affect the time, okay, to come down. Okay, so the time will be equal because the vertical distance has to be covered is the same. Okay, that what is. Now the horizontal distance of book travel while it is in the air. See the speed of the book just before it reaches the floor. Okay, now we have to find out about the speed, right? So speed will be given by this. Okay, so this what it is. Okay, so these are going to be the two components. Okay, so here Vx is this and this is minus, you can say Gt it is going to be. Okay, so this is, it is going to be, let me change this. So this is V naught into T, this is for horizontal component and it is going to be minus Gt, right? Because this is Vy is what? Vy is V naught minus Gt, right? So this is going to be V naught is 0. So you can say, so V, you can say initial velocity along Y direction is 0. So here it is going to be, you can say minus Gt J, right? J component, right? So that's what it is. Now here it is going to affect because X component is getting affected. So the speed of the book just before it reaches the floor. In particular, does each of these quantities stays the same, double or change in another way? Explain. Okay, so we have to see. So here you have see that the range has changed, right? Horizontal distance get doubled. Horizontal distance is doubled, right? Yes, is that okay?
Yes, sir.
So horizontal distance is doubled. Vertical, you can say that the time, no change in the time to come down, that is there. And if I see the velocity, so here the velocity for vector for this, it is going to be v naught t square plus gt square, I will say, and square root of that. So this is nothing but it is going to be in terms of t square is going to come out, and I can say this as, so this is v naught only, not t here. Okay, so that is again, so it is going to be, okay, so it is going to be this, so v naught square plus gt square, that what it is. And in the second case, this is v1, and what I can say in the second case is v2. This component is only changing, right? So you can say 2 v naught square plus gt square, right? So you can, now this is going to be, you can say 4 times, right? So this, it is going to change. So velocity, magnitude on touching the ground will be more in second case. Okay, will be more in second case, right? Okay, and that is quite obvious, right? Because see, potential energy is getting into converted into kinetic energy, right? So here, since the height is same, so the change in potential energy is same, there has to be the change in the kinetic energy, right? Okay, so that what it is. So the magnitude in the second case is going to be more, right? And how much is more? You have to calculate. This is, if this value is given 2 v naught, so it will become 4 v naught square plus this. So this will be what? This is v naught square plus gt. I can say this is v1 square. So you can say 3 v naught square plus v1 square it will be. Okay, square root of that. Okay, so you can modify this and you can work it out on this particular value. So what has to be this value? So you can say v2 square minus v1 square, it is nothing but it is 3 v naught square, it will be this value. So v2 will be greater than v1. Yes, is this okay?
Yes, sir.
Okay, so this is question number 4, right? Okay, let me download this. This is question 4. Okay, so let me check, let me clear this. Okay, let's see question number 5. Okay, what it says is that at the instant that you fired a bullet horizontally from a rifle. Okay, so it is a rifle case. So let's try to make our rifle. So let be my rifle be something like this. Okay, so okay, so this is my rifle. At the instant then that you fired a bullet horizontally, right? So we are firing a bullet. So let the bullet be made up of copper. Okay, so it is like this. A bullet from a rifle. You drop a bullet from a height of the gun barrel. Okay, so one bullet is dropped from the height of a barrel. Okay, so it has been dropped. Okay, if there is no air resistance, which bullet hits the level ground first? Okay, so you see that there is one bullet which has been dropped like this, and then there is another bullet which has been dropped. So you can say there is another bullet which has been dropped. Okay, and say it comes down, say it is at your arm's height, and let me call this as for simplicity, let's take that height as h. Okay, so this is h. Okay, now this bullet will go like this, and after some distance it is going to fall, right? So that has to be the path of this particular bullet. Yes, it is going to be like this, and this particular bullet will follow this path. Okay, okay, if there is no air resistance, so we will neglect the air resistance. However, air resistance becomes significant sometimes. Which bullet hits the level ground first? Explain. Okay, so we have to explain this. Okay, so let's see. Okay, so this is the situation. Now if this is height h, and suppose this is having horizontal component, right? Say let the horizontal component will be u. Okay, so this is equal to ux, and uy it is 0, and there is always g acting over here, right? So the distance horizontally it is going to cover is, you can say x is ux into t, as ax is also 0, right? Okay, so because there is no air resistance, so we'll take it ax is equal to 0. So that what it is. So x distance covered will be this. Okay, and what can I say is that then this is g, right? So if g, and for this particular bullet, we know that linear equation, right? So h is equal to uy into t minus half gt square, right? This is the time to fall this particular height. So if I see that this time is what, 2h upon g square root. This is the time to fall to ground. You can say this is bullet number 2 and this is bullet number 1, right? Bullet 2. Yes, for bullet 2 this will be the time to fall the ground, right? Fall to the ground. Yes, is that okay? Now let's try to see about this particular bullet, right? So here x is ux into t and uy is 0. Okay, so h, so h, or you can say y coordinate, it will be given by what? It is going to be uy into t minus half gt square, right? It will be given by this formula. Yes or no?
Yes, sir.
Okay, so for this you can say, okay, so this has been dropped, so here uy is equal to 0 because this has been dropped, right? The difference is that this has been dropped and this has been fired horizontally. Okay, here uy will be equal to 0 because the bullet has been fired horizontally, right? Since the bullet has been fired horizontally, so okay, so that's what it is. Okay, so these are the two cases. So you see that here y is nothing but it is minus half gt square again, so that is nothing but h. So you see that time again here it is going to be 2h upon g, right? So you see that this is for bullet 1, right? So what we can say? We can say that since the time to reach the ground for both the bullets, for both the bullets is same. Okay, since the time to reach the ground for both the bullet is same, hence what he was asking about here is that which bullet hits so both the bullets are going to hit at the same time, right? Same. Hence both the bullets strikes the ground at the same time. At the same time. Is that okay?
Yes, sir.
Okay, so that what it is. So here, but see here you have to see that reasoning is different. Here one bullet is dropped, so it will follow this particular one dimension motion, right? So this is the case of one dimension motion, right? And this is the case of two dimension motion, right? But the results are same. Yes, is that okay?
Yes, sir.
Okay, all right. So let's look. This is question number 5. Okay, then let me clear this. Let's move with the next question, right? And now let's look at question number 6. A package falls out of a plane that is flying in a straight line at a constant altitude. Okay, so so this is question number 6. So there is a plane. Let me draw my plane. So this is the plane. Okay, okay, and then there is a packet which has been dropped. Okay, okay, a package drops from plane which is flying at a straight line at a constant altitude and a speed. So you can say it is flying. So it is ux is equal to u. It is flying like this, and say it is flying at a particular height from the ground, and that height we let's call that as h, right? Okay, so it is like this particular you can say the object is dropped. So now this object, the moment it was in contact with the aeroplane, it was having the velocity same as, due to inertia, the same velocity as the velocity of plane. Now this packet will come like this. If there is no air resistance, it will fall somewhere, right? It is going to fall somewhere here. Okay, so it will fall somewhere here. Okay, so it is like this. Okay, if you ignore the air resistance, okay, that's what he says. If we ignore the air resistance, okay, we have ignored it. What will be the path of the package as observed by the pilot? Okay, all right, as observed by the person on the ground. Okay, so now he is talking about, you can say, the path. Okay, now you see that the path is going to be what? Okay, there are two persons, so let's call one person is over here. Okay, and one person is over here, right? Okay, so what has to be the path, right? So if you see that this person here is stationary, right? Okay, okay, so what we can say is that this person is stationary. Okay, stationary person. Yes, so what has to be your answer? Okay, yes, Anshu, I want to ask you what has to be your answer in this case. If you are standing here and suppose there is a pilot, okay, so what has to be your answer? Okay, for the pilot it will be straight downward motion. Yes.
Yes, sir.
Okay, and this man, this will see a parabolic path, right?
Yes, sir.
Okay, so this man will see a parabolic path, and for, you can say, you can also experiment this, right? When you can experiment this while you are traveling in a train or a bus. Okay, from the bus, if you drop something, no, so you will see that for you it is going straight away down, right? So that particular object will be going straight away down, right? For it is, you can say, one dimension motion it is going to be, right? But if you are standing on that, what you are going to see is that this particular object, it is going to fall like this. Okay, all right. So for example, this is the case in case of bombs also, right? So if suppose there is a military man over here, and there is some aeroplane which has come, there is some fighter airplane which has come. Now the moment it will see that this is the establishment, right? Okay, so what happens is that for him the bomb is going to follow like this path. Okay, you might see the trajectory, but for the pilot it is going to be straight downward motion. So that's why you know the selection for the pilot is very critical. If he makes like 1 second difference, the you can say the packet may land at altogether a different place. Okay, so this is you can say that for fighter pilots, especially pilots, the judgment of the time, the judgment of time is critical. Okay, so that what it is. Okay, because you see that here it will be fired and it will go like that, and from the here if you see, you can see, you can witness this while you are traveling in train, from the train window if you try to drop. So you see that you see that particular object is dropping straight away. Okay, and you will move forward, and you will see that this particular object falling downward. Okay, right, it is going to be like this. Okay, so for fighter plane the judgment of time is very critical. If 1 second they are delayed, the you can say that package might land over somewhere else, right? Okay, yes, is this okay, clear?
Yes, sir.
Okay, so you see that there are two different persons and they will experience two different paths, right? So for them the motion is going to be different. For you can say for fighter pilot it is just the one dimension motion, and for you can say the person on the ground it is a parabolic path. Okay, so that's why they can design anti-ballistic missiles and all. Right now that we know that now in the Israel what has happened, right? There is like lot of you can say a lot of missiles were fired on Israel from Gaza Strip, and they had something which they call as uh, David Sling or something like that, which Iron Dome, right? So that was a missile defense system which they had, and which went on destroying all the, you can say. How does that happen? Because that particular, you can say, that is an observer, that Iron Dome, or you can say that is an observer, and it what does it does it calculates the trajectory of that particular projectile, and once it calculates the trajectory, it locks the target. Okay, that is the path it is going to follow. Then it hits that particular you can say projectile, and it destroys that particular you can say projectile, right? Okay, so like that the things work. Okay, so this is question number 6, right? Okay, now let's look at question number 7. What does question number 7 says? Okay, question number 7 says that sketch the 6 graphs of x and y component of position. Okay, 6 graphs. Okay, we have to sketch position, velocity and acceleration versus the time for projectile with x is equal to 0, y is equal to 0, and x, okay, 0 to, okay, this is angle of projection, right? Okay, 6 graphs. Okay, components of positions. Okay, so which 6 graph is asking? Okay, I think let's try to draw. Okay, so there is the projectile which is over here. Now what is saying is that x naught y naught is 0. So x naught equal to 0 and y naught equal to 0, right? So this is, you can say, y, and this is x, right? Okay, and 0 to 90, alpha is 90 degree, in that it has to be, it has been projected, right? Okay, position, velocity and acceleration versus time for projectile. Okay, so this means 6 graph. Okay, so 3, 1 is for, you can say, position, velocity, and okay, in this angle we have to draw. Okay, so if I have to, position graph is going to be like this, right? Okay, so the position graph is going to be like this, and this is going to be, you can say, x max, that is the range. Okay, and this is, you can say, y max. So this is x and y, so y max, that is the height, right? Okay, maximum height. Okay, and this is for, say, some angle alpha between 0 to 90 degrees. Okay, so this is going to be one, and here this is one angle we can take, and then the other angle, like we know that the range is same for 90 minus alpha. So this is alpha. So if I take the other angle as 90 minus alpha, for that also the range is going to be same. So the other graph is going to be like this, right? Okay, so this is 90 minus alpha. right? So you can see, since the range is same, the time is same, right? Time for the flight is going to be same, right? Since the range is same, right? Okay, so here this is going to be, you can say, y max mx1 and this is y mx2, right? So there is the difference in the height, okay, but the range will be same. So these are the two graphs for, you can say, position. Is this okay? Yes. Yes, Anshu, is that okay? Now let's talk about velocity, right? So here we have, say, u as velocity. So it will be this, and here the velocity component, what can you say if it is having some magnitude? Okay, so let's call this magnitude, this is the velocity and this is time. Okay, with time this is, so these are the two graphs. Okay, and now velocity, if velocity is, you can say, velocity vector will be given by vxi plus vyj, right? It will be given by this. Now what I can say about this, so Vx is always how much? It is going to be u cos alpha, okay, or you can say u cos 90 minus alpha, right? Okay, so that is, you can say this, ux this my, okay, so that is, you can say, this component. And what is Vy component? Vy component is going to be u sin alpha, right, minus gt, right? For the time it is going to be this. So we'll plot for two different values, right? One is for, you can say, alpha value, and then other is the complementary value, right? So these are the two graphs for this. We have to draw these two graphs for this. So the velocity will be given this. You can say it is going to be u cos alpha. Okay. All right. So here you see that the x component is going to be same. So what I can say about the net velocity? The net velocity is going to be, you can say, this is going to be this square. So u square cos square alpha. Okay, plus this square. So that is what it is, u square sin square alpha, right? Plus, or you can say this is square, so it will be minus, you can say, u sin alpha into gt, right? Plus g square t square, right? It is going to be this. Now here you can take it this common, and what it is that it will get, velocity will be given by u square, and this is 2 times here, minus 2 u gt sin alpha, right? It will be this plus g square t square. Yes, is that okay? It will be given by this.
Yes, sir.
Okay, so you see that this particular, at when time is 0, so this component will be 0, this component will be 0, so it will be u, it will start from u, right? Now what will happen when time will be, you can say, maximum, right? So here if it is starting with this, and here if it is horizontal ground, the entire, you can say, the kinetic energy will get converted into potential energy. Okay, where it will have, you can say, only the x component. Okay, so this is the time, we have to substitute these values actually. So what is this time? This time is, you can say, this time is u sin theta by, what is this time? So this is u sin alpha by g, that is the time of half flight, right? So at this, if I put this value, it is going to be, what it will become, g will be cancelled, minus 2 u square sin square, you can say, alpha will be there, and plus g square t square. Yes, let's try to calculate this particular value. Okay, let me first, okay, let me first save this because I have limited space here, and this is, let me call this as question 7a, and let me do for velocity in a new sheet. Okay, let's, okay, so v will be given by vxi plus vyj, right? Okay, so this is question 7 second part. Okay, let's call this. Okay, and vx is what? Vx is, you can say, u cos alpha, right? And vy will be what? It is going to be u sin alpha minus gt, right? Okay, so here the magnitude of velocity, we are just concerned on the magnitude of velocity so that we can sketch the graph. So that is nothing but this square plus this square. So this is going to be what? It is u square Okay, so this will become u square minus 2u gt sine alpha, right, plus g square t square, right? It is like this. And what is time? So time, you can say, to reach the maximum height. Okay, so this time is going to be what? When Vy is 0. So when Vy is 0, okay, so time for Vy is equal to 0. So what is that? That time is nothing but, that time is u sine alpha upon g, right? If I plug in this particular value, what will be the magnitude? Let's see. And the magnitude of the final velocity component will be same because of symmetry, right? So u square minus 2u g, and this will be what? It is u sine square alpha, it will become, divided by g plus g square, and this is u square sine square alpha upon g, right? G square, right? So this is gone, and you see that this is also gone, and sine square alpha. So what is this? This is going to be a simple value, that is u square minus 2u square sine square alpha and plus u square. So it is minus u square sine square alpha, right? So you see that this will get modified to u square 1 minus sine square alpha. So what I can say, this is nothing but u cos alpha, right? Okay, so the magnitude of velocity is always u cos alpha. Got it? Yes, yes or no? Oh. So the magnitude of velocity is always u cos alpha, right? So what I can say this here. Okay, so the graph, if I have to draw, the graph is going to be what? The graph of B versus T. It is always going to be a straight line. Okay, this is u cos alpha. Okay, now alpha, you can say we have two alphas, alpha and you can say 90 minus alpha. So you can say u cos alpha, the other one is going to be u sin alpha, depending upon the value of you can say alpha, right? Okay, so they are complementary angles. So u cos alpha, the other is going to be, the other graph is going to be also like this, B versus T, and that is u sin alpha. Yes, is that okay?
Yes, sir.
Okay, all right. So let me save this. This is question 7B. Okay. Now let's now talk about the oscillation, right? Okay. So let's talk about oscillation. That is question 7 third bit, right? Okay. So what we can say here it that to say here, oscillation will be given by what? It is AXI plus AYJ, right? There are two components, X and Y, right? So AX is always 0, we know that, and AY is what? It is minus Z. Okay, so the mod of A, it is always going to be, you can say, mod of AY. Okay, that is nothing but G, and it is always X downward. Okay, so the graph here, it is going to be, again you can say, this is this graph is going to be, this is G, right? Okay, so AY is always G, yeah, that's what it is. So if you can say this as it is again a constant. Okay, so it is going to have only one component, that is G component. Okay, so whatever the value of G is, sorry, whatever the value of you can say of alpha, that is angle of projection is, the oscillation is constant. Okay, in case of velocity, the velocity dependent upon the angle of projection, right? But here it is altogether a constant, right? The projection is of the projection, the angle of projection, whatever the value of angular projection is, the oscillation is constant value, that is G. Okay, and always directed towards the center of Earth, right? And it is always directed towards the center of Earth. center of earth, right? So if this graph, if I have to draw, how I am going to draw this graph, I can simply say that to draw this graph I am going to draw it like this. So this is time t and this is on negative side acceleration, right? So this value is always going to be this, that is minus g, right? The graph will be like this. So both for, like you can say here, the graph is going to be only one. Is that okay?
Yes.
Okay, all right. So let me save this. This is question 7c. Okay, so let me wind up here. I have to cook my food also. Okay.